I'm Nikki Ashari.
I'm Chase Verstuff.
I'm Emily Goebel.
Our fourth team member is Luli.
And we are senior bioengineering students at the University of California, San Diego. We are Team 22, lower body, negative pressure, fluid shifts countermeasure suit for long duration space flight.
We are sponsored by NASA and we work out of the UCSD Department of Orthopedic Surgery.
The problem we are trying to address is due to the headward fluid shifts that occur in astronauts that have spent long durations of time in microgravity environment, such as those in a long space mission or time on the ISS. Here on Earth, gravity prevents the buildup of bodily fluids in the chest and head and naturally causes downward fluid shifts. In microgravity, up in space, however, blood and other bodily fluids that accumulate in the chest and head cause intense intracranial and intraocular pressure, which can lead to serious health problems such as eye damage and head pain.
Our lower body negative pressure suit, which you can see Nikki wearing here, induces negative pressure across the legs through use of this vacuum, which causes a downward fluid shift throughout the body. Our suit is composed of airtight material, a rigid structure that prevents the collapse of the pants across the legs, and a docking port, which you can see right here at the lower ankle, that allows for the release of excess pressure through a pressure release valve, a port so that we can connect our pressure transducer, which allows for pressure measurement, and a connector for the vacuum, which, as you can see here, our vacuum has a one-way check valve to allow for the retention of negative pressure in the pants.
You're probably wondering why I'm in a head-down tilt. We do this so we can mimic the effects of microgravity and then utilize our LBNP trousers to combat the effects of cephalic fluid shifts and also reduce an increase in intracranial pressure. Now, we also use the CCFP, which is the cochlear cerebral fluid pressure system. Essentially, it's an effective tool to measure the amount of fluid accumulation inside the cranium. So why is this all so important? Why is this important for space exploration? Well, as you know, Earth has an expiration date, and so does everyone on it. And it's important that we think of other alternatives, other techniques to develop to help sustain life outside of Earth.
Additionally, in the more short-term range, we want to protect the health of our astronauts, and with space missions, especially those going to Mars, getting potentially very, very long, and the amount of time that astronauts spend on the ISS also increasing, we want to ensure that astronauts come back to Earth with very little, or hopefully none, health problems.
Our prototype between the two iterations costs about $300 for us to produce.
This has been proven to be a very cost-effective way to reduce intracranial and intraocular pressure.
We would like to acknowledge the entire Hargens Laboratory, Dr. Lonnie Friedson, Dr. Alan Hargens, Robert Healy, Rachel, and everyone on the team that has helped us develop this suit.